In this video, I would like to explain Bayesian inference through a battery production factory example. This is the question I got. It's German. Aber mein Deutsch ist nicht so gut, deshalb mache ich es auf Englisch. Here is the Übersetzung auf English. The program state there is a battery factory and two machines produce batteries. Some defects are from machine A or machine B and so on. At the end, I need to calculate the defective probability and machine A production probability. This is a question about conditional probability. It is called Bayesian. First, I'd like to explain my notation. I draw a square. The dimension is 1 by 1. The area represents the probability. The total probability is 100%. 100% means everything happens. It's 1. So what does it mean? Let me show you an example. So I draw square again. Suppose you flip a fair coin. The probability of head H is here and probability of tail is here. This length is 0.5 and this length is also 0.5 for whatever unit is. The total probability is always 1. pH is the probability of the head, and the area is 0.5 over 1, this area. That means 1/2. The same as the tail's probability. Tail's probability is also half, and total is 1. Why did I draw this figure? Because in this way, I can show you a conditional probability, Bayesian. For the battery factory case, there is a defect probability, P, D is this area. I don't know what probability is, so let's say 20%, 0.2, and the rest is not defective, which means it is a good one. Then the probability of good is 0.8, 80% in this case. This is defect and here is good. The question said when a defect happens, I will write this. I will write the conditional probability. That is P probability given D and A happens. There is some probability here. This is the probability A given D. This bar means given. So given D, under that condition, A happened. You can think D has already happened under that condition. What is the probability of A? It's written here. This left rectangle is all defective. Please note, the 100% is changed by the context. This defect rectangle has already happened. This is now 100%. Then 30% of that is from machine A. Do you see that? The 100% depends on the context. The square is the whole interested world. This is 100%, but now I'm only interested in the defects. Therefore, here is 100% and 30% of this rectangle. Because defect already happens. In the Bayesian, probability updates when you know something more. It's natural that if you know more, the probability changes. This is how I draw the Bayesian probability. Here is 30% of the rectangle, but I don't know the actual area regarding to the whole square. This area can be computed by PA given D times PD. I know PA given D is 30%, but I don't know PD. Now I will explain Bayes' theorem. I use A and B here. It is not the machine A and B, it is general A and B as event. The Bayes theorem is the probability A given B is equal to probability B given A times probability of A over probability of B. This is Bayes' theorem. When I learned this, it is given as truth. But for me, this was confusing. I had no intuition, no feeling. I could solve the problems, but I didn't know the meaning. For me, math is a language, so I should have asked what is the meaning. But later, I saw some geometric meanings. However, to solve the problem, you don't need it. Still, the next two explanations are my motivation to make this video. I want to tell you. This is the area of probability of B. But you can see this as B has already happened in this area. And this is not B happened area. Then given B has happened, this is A happened. Thus A given B. Please note, A can happen when B has not happened. So I will write this. When B has not happened, there's still A happened area. So here is P, A given, not B. This symbol is not. Now you see what's the Bayes theorem in this square. You can also fill other rectangles. My next question is why this is correct? Why this equal relationships? So I shaded P A given B. P A given B is a ratio. Its denominator is B happens, this rectangle part. And the numerator is A given B part, this shaded area. And this is equal to the probability B given A, where is A happened area. This is A happened area. B happened and A happened, or B not happened, A happened. This part is A, and this is A given B. The ratio is, denominator is A happened, and numerator is A given B part. Now, what is the probability of A? The denominator is whole square, and this part, A happened part, that's the probability of A. Or maybe I should use a yellow color to make it clear. What is the probability of B? Here is the B happens rectangle. So the denominator is whole square, and then B happened rectangle. B happens is this rectangle. Now you can simplify this. You can cancel this and this and this and this. You see the remaining is the same. Oh, I should shade it this part. I color the B rectangle red to make it clear. This part is the B happens area. This is also B happen area. And you see both sides are the same. They are equal. This is the meaning of Bayes' theorem, okay? However, actually I still found this is difficult. So I have another explanation. Here I draw a Venn diagram. Let's say this is A happens area and this is B happens area. This part is A and B happen. Let's focus on this intersection area. This area is the probability of A and B. Now think about A happens case. I draw A happens part. So here is the intersection. The intersection is B happens given A. The area is PA times P. A happened and B happened. B given A. This is this area. The B and the intersection are the same story. Think about the intersection. This area is P, B times probability of B happens and then A happened. And these areas are the same. It is just intersection area. You can divide both sides of PA. Then PA cancels out here. That means P, B given A is equal to P, A given B times P, B over PA. This is the Bayes theorem. I hope now you can see why Bayes theorem works. If not, please ask me a question. I think this explanation is a bit better. Let's back to the question. Batteries are produced in a factory. There are two machines, A and B. 30% of the defective batteries in the total daily production of both machines come from machine A. This is about defect and machine A production. I know the probability given defect and then A happens is 30%, 0.3. Now 20% of the good batteries in the total daily production of both machines come from machine B. Now given good one, and that is from machine B, this probability is 20%, 0.2. 6% of the daily production of A are defective batteries. This case given A, and defective, this probability is 6%, 0.06. Now, question A asks about the probability of defective, A asking PD, and B asking probability of A. Okay, let's try to solve this. I will draw my Bayes figure. I don't know yet how many defects and good ones, but just say PD and PG. There is A given D. Defect and A, 0.3. This is P, A given D. Here is 0.3. This means B given D is 0.7 because there are only two machines A and B. Given G and B with 0.2. This means here P, A given G, which is 0.8. Again, there are only A and B machines. They should sum up to 1. There is another view. That is machine A, PA, and machine B, PB. I don't know which is larger, maybe A is larger. The probability of defect given A is 0.06. Oh, the figure is not scale. Then the good one given A is 0.94 because machine A produces goods or defects only, not good and defect mixed. That sums must be 1. Now let's use the Bayes theorem A and D. PA given D is 0.3. PD given A is 0.06. We don't know PA, we don't know PD yet. I can divide both sides 0.06, this is 5. Then 5 times PD is equal to PA. Okay, I write it down here. We still have a relationship between B and good, but I think we don't know B well, so I use a relationship between A and G. Let's write Bayes' theorem for A and G. See these figures, A given G is here, it's 0.8. Then good given A is 0.94, and I don't know PA, and PG. I don't know PG, but I know PG is equal to 1 minus PD, because if a battery is not defect, it should be good by assumption. So I can rewrite this PG to 1 minus PD. 1 minus PD. Then just solve for PD. 80 times 1 minus PD is equal to 0.94 times PA. I will distribute this 80. 80 minus 80 PD is equal to 0.94 PA. We know PA is equal to 5 times PD. 80 minus 80 PD is equal to, oh, this is not 0.94, it's 94. So 94 times 5 times PD. I will move the PD to the left-hand side. 94 times 5 plus 80 times PD is equal to 80. 80. There's no space left. I will continue. I use my calculator. 94 times 5 plus 80 is 550. 550 times PD is equal to 80. Both sides divided by 550 and zeros are cancelled out. This is PD. PA is equal to 5 times PD. Let's calculate the value. 8 divided by 55. That is 145. It's 0.15. PA is 5 times PD, so 5 times 8 over 55. And this is cancelled out, 11. 8 over 11. This is calculate again. This is times 5. Okay, 0.7272. So 0.73. Then the answer of A is 15% and B is 73%. I hope this is correct and I hope this helps. Thanks for watching.